Today we're going to be finding out how to find magnitude and direction of a vector. You will need a calculator for this one to make sure you're in the right mode, degree mode. But first, let's review a little bit of things from yesterday. How would we write the vector if its initial position is at -3, 5, and its terminal point is at 5, -1? Well, very easy. Remember, it's always going to be terminal minus the initial. Can't spell today. There we go. Terminal minus the initial. So if I want to write it in component form, very easy to do. We're going to take the terminal, which is 5, the difference in the x's, 5 minus a -3, and -1 minus 5. So that's going to give us 8, -6. And there's our vector, 8, -6. To put this in standard unit form, remember this has our i's and j's, right? That has our i's and j's. We would write this as 8i minus 6j. Now, some teachers don't put the hats on the i's and j's. I do. That's cool. Alright, so for the next part, change the following vectors from component to standard unit. Well, we just did that. So the first one should be pretty easy. -3, aye, Captain, plus 9j. So I'll let you guys do part B here because that 0 might mess you up there. So how do we convert from vector, from standard to component? Well, it's the same thing. Remember, that's my change in x. That's my change in y. So it's going to be 2, 6. Now to get vector v over here, we will have to distribute, of course, first. And we get -2i plus 4j. So that's going to become -2, 4. One of the easiest things you'll ever do. Alright, so let's take a look at C here. C says let v equal this vector and u equal this vector. Find vector w if w equals 2v minus u. 2v or not 2v? So we can go 2 times vector v, 2i minus 3j, minus u, put this in parentheses. You don't want to make a mistake with parentheses. Calculus kids do it all the time. It really annoys me. So if you know a calculus student, please tell them parentheses. Alright, so there we go. Combine your like terms, just like yesterday. I minus 7j. Now, that is standard unit form. To put this in vector form, 1, -7. Don't forget your chevrons on those. Very easy to do, and in under 3 minutes. Alright, now, how do we find magnitude and direction of a vector? Well, yesterday we did magnitude. Today we're really going to be taking a look at the direction of a vector. So first, let's just look at any arbitrary vector, and we're going to call this vector x, y. Now, if we were to graph it on the x-axis and the y-axis, it starts at 0, 0. Imagine it starts at 0, 0, and it ends at some arbitrary point x, y. So I can draw my vector. There it is. Now, from yesterday, we learned to get the magnitude. To get the magnitude, we just use Pythagorean theorem. Remember, this is length y, this is length x. So to get the magnitude, we would call that the magnitude of vector v would equal the square root of x squared plus y squared. That's our magnitude. To get direction, well, direction deals with the angle it travels. So, and it's really kind of cool because, hey, look, we got a right triangle. We can actually find that angle theta right there. And since I'm given already the opposite and the adjacent, we can use cosine. Just teasing. Tangent, of course. Okay? So we're going to use tangent. To get the tangent of the angle, it's going to be equal to x over y. And that's going to give us our angle right there. So we might need a calculator for some of these problems here. So let's take a look at a couple. Here we have vector v. Draw it out. Started at 0, 0. It goes right to, up to. Draw your arrow. It's directional. Vectors are directional. Okay, so if I want to find its magnitude, this is up 2 over 2. To find the magnitude, don't give me no magnitude. To get the magnitude of vector v, it's just going to be the square root of 4 plus 4. 2 squared plus 2 squared, which is the square root of 8. There's the magnitude. That's how long this is. This is the square root of 8 units. To get direction, that's today's lesson. To get direction, we're going to take, to get this angle theta, we're going to take the tangent of the angle equals 2 over 2. Tangent of theta equals 1. And we should know this. Where does tangent of theta equal 1? That's at what angle? We should know this one. This is one of our known trig values. Pi over 4 or 45 degrees. All right. We might have to have a pop quiz over trig values if you don't know those. All right. So for number 2, a little bit harder here. Draw out your vector v. It says go left 3 this time and up 4. You know, let me redraw that down here. That looks awful. Left 3 and up 4. There we go. Starting at 0. That's where it's headed towards. I know this length is 4. This length is 3. So if I want to find its magnitude, the magnitude of vector v is just the square root of a squared, which is 9, plus y squared, which is 4, which becomes 16. We get the square root of 25, which is 5. So the length of my vector is 5, but I want to get the angle. Whoop, we don't measure there. But remember, when we measure the angle, we measure off the positive x-axis. So that's theta in this case right here. We still treat it the same, basically, so don't worry much about that. But if I want to get the angle here, I'm going to use the tangent of the angle, theta. I'm going to use this angle right here. It's 4 over 3. Now, I don't know what that is, okay? So I'm going to use my calculator. To get theta, it's the inverse tangent of 4/3. Use my calculator. Second, make sure you're in the right mode. Let's use degree mode. Second tangent, 4 over 3. Enter. Theta is 53 degrees. But remember, that 53 degrees is right here. That's this angle right here. That's 53 degrees. It's kind of hard to see, but that's 53 degrees right there. To get our angle, we have to get 180 minus 53 degrees. And take 180 minus 53, we get 127 degrees for our angle. So a way we could write this vector sometime, we can actually rewrite the vector like so. And it's kind of cool. We could write the vector as 5, 127 degrees. And that's the same vector. It goes out 5 units at 127 degrees. Same thing here. I could rewrite this vector as the square root of 8, 45 degrees. It goes out square root of 8 units at 45 degrees off the x-axis. And that's how we measure that. We're going to talk a little bit more about these tomorrow too. All right, let's take a look at the next page real quick. All right. If we know the angle at which a vector is headed, we can actually use right triangles. The angle at which a vector is headed, we can use right triangles to write the vector in standard form. So let's say we have some vector. Now we just kind of talked about this. We can write the vector as in terms of its magnitude and its angle. It's just another way to write a vector. So in other words, if I were to kind of sketch this out, I'm just going to use the first quadrant. We have a vector heading to a certain point, x, y. We know its magnitude, and we know its angle. But I want to write this in standard form. So in order to do this, we're going to draw a right triangle. Remember, this is just the height y. This is the distance x. And from a little bit of trigonometry, we know, remember this, that the sine of the angle is the opposite, which is y, over the hypotenuse, which is our magnitude. the same thing for cosine of theta, the adjacent over the magnitude. Now, using a little bit of algebra, we can cross multiply. So what does y equal? So what does the y coordinate equal? Well, if I cross multiply, the y coordinate will equal the magnitude times the sine of the angle, where the x coordinate will equal the magnitude times the cosine of the angle. And to write this in standard form, now this is going to be kind of lengthy. Matter of fact, I'm going to write it down here. To get the magnitude, remember it's delta x in the I direction plus delta y in the j direction. So if I want to write this, there's my x. This becomes the magnitude times the cosine of the angle in the I direction plus the magnitude of the angle, the magnitude times the cosine of the angle in the j direction. And that's how we could write these. All right, when you go to part 2, we're going to take a look at a couple of examples. So if you need to go back and try some more, that'll be fine, okay?